Okay, for section 7.4, as the title tells us, we're dealing with rational exponents. In our context, the word rational really means fraction. So this may be the first time, I don't know, but we're going to be looking at expressions, exponential expressions, where the exponent is actually a fraction. So one of the things that I want you to be able to take away from this lesson is I've actually given you some true statements here at the bottom of my screen, and I'm kind of curious as to whether or not you can see or tell me maybe a particular pattern that shows up. Is there something that you notice that happens when you change from rational exponent form, which is what this would be called, 7 to the 1/2, into radical form? From here, rational exponent into radical. What is true, Josh?
For the fractions, I guess that's what it is, right? It's like the numerator is the exponent and the denominator is the index. Exactly.
I guess all of you heard that, and he's picked up on what is true when we change from rational exponent to radical. The denominator is always the index, or the root. The top number, the numerator, will always be the exponent, and I didn't write 1 because we don't write the exponent 1, but it's implied that it is there. So same thing here. This is another way of saying the cube root of 4 squared. The denominator is the root. The top number will be the exponent for 4, and so forth. And I just did the same thing going the other direction, because some of your homework tonight, you'll be taking radical form and writing it in rational exponent form. So notice, again, the root, which is the 2 that's invisible, is the denominator. And the 1 exponent that we don't see is the numerator. Okay? So notice how we take the cube root of 8 squared and we write it as 8 to the 2/3 power. All right, so this is a big part of today's lesson, from rational exponent to radical and vice versa. Okay, so with that said, let's put this into practice. You do not have to write the objective. I'm going to give you some examples that correspond to problems 2 through 8 even on your homework. The directions, very simply, just say to simplify. So you need to think of these rational exponent expressions as radical expressions. So I'll just do this one for you. 64 to the 1/3 power in radical form is the cube root of 64, again, to the 1st, but we don't write exponent 1. So I just changed rational exponent into radical form because that's fairly familiar to us. The cube root of 64, of course, is just 4. Okay, letter B. There's really 2 ways of thinking about letter B. Reviewing the rule of exponents that says multiplication using the same base, which we have here, 7 is the base. That means that we could get our answer by writing the base and then adding the exponents together. So what is my final answer here? 7 to the 1st, which is just 7. Okay, so that's one way of thinking about it. But using our what we just talked about, changing rational exponent into radical form, you could also think of it as the square root of 7 times the square root of 7, and any radical times itself, the result is what? Well, the result is just the number underneath the radical. We call the radicand. So square root of 7 times square root of 7 is 7. So really 2 different ways of coming up with 7 in this problem, but I just want to stick with our theme of changing rational exponent form into radical form. All right, maybe I can get a volunteer. How would I change 5 to the 1/3 power to radical form? 5 to the 1/3 power as a radical. Yeah?
Would it be 3 radical 5?
Let me say it this way. It would be the blank root of 5. Okay, the cube root of 5. And same thing here. This would be the cube root of 25. The denominator is always the index. We multiply those together, and we get the cube root of 125. And what's that? 5. So I just want to pause for just a second and make sure you understand how rational exponent form can be made into radical form. Any questions so far? Okay. I've got a couple more. Volunteer for letter D. Anybody want it? Change these into radical form and then simplify. Well, I'll just call on. What about Grant? How would you change 2 to the 1/2 power into radical form? Okay, so both of these in radical form, square root of 2 times square root of 8. Obviously, that's the square root of 16, which simplifies to 4. Okay, what about letter E in radical form? Let's see if Allie can help us with that one. The cube root of, actually we're just going to say the cube root of negative 64. You're only going to use the number I if the index is even. Okay, so is there a perfect cube root of negative 64? Is there a number that would multiply times itself 3 times to give us negative 64? Negative 4. So that would be our final answer. Okay, any questions so far? Because we're about to switch gears and we're going to go from radical form to rational exponent form. So just going the opposite direction. So that's what you're going to do in problems 18 to 24 even. You'll be given radical form and we just have to write the rational exponent form. So let me start with Matthew for letter A. How would that look as an exponent that's a fraction?
2/7.
Okay, so it would be x to the 2/7 power. All right. Emily, what about letter B? C to the 3/4 power. All right, and don't let the parentheses fool you, because writing this using parentheses really is the same thing as writing it in this way. There's really no difference there. So, Gwen, what would you say on letter C? E to the 5/3 power. All right, let's see what we got. One more. Austin, what about letter D?
It would be
3 over 2. Yeah, this is a square root, so it would be a to the 3/2 power. Okay, so easy enough. Any questions so far? So now you know how to go from radical to rational exponent and vice versa. And now let's see, so I can show you what problems we're about to address. On your homework, we're about to do examples that will help you with 10 through 16 even. And the difference in these problems, instead of giving the exponent in fraction form, they're going to give it to us in decimal form. So it's only our job to change decimal to fraction. That's a very important first step. Always change decimal to fraction. and I'll go a little bit further than that. It needs to be reduced fraction and improper, if necessary. In other words, you wouldn't have a mixed number exponent. Okay? And we also need to refresh our memory a little bit, because this negative exponent tends to give people some trouble. I know you got that in Algebra 1, but I still find that negative exponents cause a lot of confusion for people. So I want to make sure that you understand what that does. But let's start out, first of all, what is negative 0.4 as a fraction? Reduced fraction. Negative 2/5. Everybody see that? I mean, it started off as negative 4/10, and he went ahead and simplified it into negative 2/5. All right, and I'm going to go to a new screen, because I really want to make sure you leave today not being confused by negative exponents. Okay, I think I'll start with an example that is unrelated to this, and then we'll come back to this. Okay, so bear with me for a second. We'll start simple. 2 to the negative 1 power is the same thing as 1 over 2. Okay, let's try another one. 3 to the negative 3 power is the same thing as 1 over 3 to the positive 3, or 1 over 27. Okay, I'm going to do one more, then I'm going to ask you, tell me the whole idea behind negative exponents. Here's another one. 2/3 to the negative 2 is the same thing as 3/2 to the positive 2, or 9/4. So what is the rule, the idea that we have to remember about negative exponents, Josh?
Pretty much put it on the bottom and make it positive, right?
That's true, but like in this case, where we didn't necessarily just put it on the bottom, what happened here? And the same thing's happening for all of these, but it's pretty obvious, I think, here. What happened, Allie? Okay, the base, which is the part underneath the radical, she used the word reciprocal, or you could think of it as you flip the base over. And once the base is flipped over, what happened to the exponent? It became positive. Okay, so I know you got this in Algebra 1, maybe you forgot, and some people still struggle with it, but the same thing happened here. What's the reciprocal of 3? 1/3. 3 is just 3 over 1, and we flipped it over. And once we flipped it over, what did we do to the exponent? Made it positive. Same thing with 2. The reciprocal of 2, 1/2. And once I flipped the base over, then the exponent became positive. So that rule of negative exponents is going to come up several times in this lesson. I want to make sure you get it. So now we're ready, I think, to change this. First of all, let's just change it into a positive exponent. Caitlin. I couldn't hear all that, I'm sorry. You don't flip the exponent, you flip the base. So what is the reciprocal of y? 1 over y. Okay, very good. Now, just like we did here, when you flip the base, it's simple enough. What do you do with the exponent? We flipped the base here in this example, and we went from a negative exponent to positive. So once you flip the base, you just make the exponent positive. Okay? Now we're going to go through what we learned about changing this into radical form. So Adam, what is y to the 2/5 as a radical?
Square root of y.
So the denominator is always what part of the radical?
It's
Okay, So it's the fifth root of y to the second. All right, now at this point, you're on the lookout for opportunities to simplify radicals. Can we simplify the fifth root of y squared? There is no way. 5 doesn't divide into 2. I can't write factors that would make this possible. So this is going to be my final answer. And some of you might be wondering, well, don't we have to rationalize denominators? Didn't you just tell us the other day that you can't leave a radical in the denominator of a fraction? I remember you saying that. Well, for tonight, it's okay. You can leave radicals in the denominator. You do not have to worry about rationalizing. All right? So, let's try this one. 81 to the 0.75 power. As a fraction, question, or got an answer?
81
Very good. She changed 0.75 into 3/4. Very good. So Noah, as a radical, what is 81 to the 3/4 power?
81 cubed in the square root.
Well, there's no square root, so I'm going to have you fill in the blank. It's the blank root of 81 to the third. The fourth? Yeah, it's just the fourth root of 81 to the third. Okay. Now, on your test, I think I've mentioned this before, for the section that contains radicals like this, you can't use your calculator, and it could be that you're going to simplify something like this. And that looks kind of big, and if you went ahead and found out what 81 to the third is, that's 243. The fourth root of 243 without a calculator, that's probably going to be kind of tough. That might take you a little bit of time. Well, let me show you what makes this a lot easier. Think of it this way. Let's break this up as the fourth root of 81, which isn't too bad. What is the number that would multiply times itself 4 times to equal 81? 3, okay? Now, all we have to do is raise 3 to the third power. So, in essence, this radical really is exactly the same thing as this one. So the fourth root of 81 is 3 to the third. What's our final answer? 27. So let me just recap that. Find the root of the base. The base is 81. Fourth root of 81. And then whatever that result is, you just raise it to the power. And that makes simplifying these radicals of bigger numbers that have perfect roots, it makes it quite a bit easier. Okay, follow me? Good. Let's see, what do we have? Oh, I just chose some, you can probably guess you're going to be doing the evens on page 382. So I just pulled out some random odd problems for us to practice. And let's just run through a few of these, and then I'll give you some more notes to help with the rest of the assignment. So change number 7 into radical form. Matthew, what would those be in radical form? Okay, and put those together and you have, okay, square root of 64, which of course is 8. Trevor, what about number 9? What are those in radical form? Okay, I'm going to help you out. The terminology would go like this. In radical form, this first one, it would be the blank root of 3. Fourth root of 3 times the fourth root of 27, and that's the fourth root of 81, and I think we covered this just a minute ago. What is the fourth root of 81? 3. Okay, The directions change. Just follow the directions on page 382, but when you get down to problems like number 13, you're going to be asked to write these in radical form. So Bradley, on number 13, what is that in radical form? Okay, and then you should always check, just make sure that the radical can't be simplified. And in this case, it can't be, so that's our final answer. Let's change, first of all, number 15. Let me go with Emily. Changing t to the negative 3/4 into a positive exponent.
You would do 1 over 2. Then it would become up to the bottom 3/4.
Nice. Okay, Emily, I'm going to stay with you. Now change this into radical form.
It would be 4. Index is 4. T to the 4th. T to the 3rd with the index is 4.
Okay, so I want you to fill in the blank. The blank root of t to the 3rd.
The 4th root.
Okay, the 4th root of t to the 3rd. Now, can we simplify the 4th root of t cubed?
No.
No. And we don't have to rationalize, so that would be our final answer. Let me see. Sam, can you change 1.2? This is a decimal 1.2, but we need to convert that into a fraction.
It would be
The way it is right now, you can think of it as 12/10ths, because the 2's in the tenths place. 6/5. All right. So Sam, what is that in radical form?
fifth root radical y to the 6th.
Okay, the 5th root of y to the 6th. Now, in this case, can we simplify? 5 is lower than 6, so how would we do it?
Subtract.
So we're going to, sort of like we did in our previous lesson, I'm going to come up with 2 groups, perfect fifths times not perfect fifths. So, Emily, what will go in the perfect 5th root group?
I'm going to say a question.
Oh, okay, go ahead.
How did you say you got 6/5 again?
6/5, we started off making this 12/10. And if you don't understand 12/10, you could start off as 1 2/10.
I thought it was 1 times 2.
No, it's 1.2.
Oh, okay.
It's a decimal. My writing's not real good. Okay, so what's going to go in the perfect 5th root group? I need a number less than 6 that's divisible by 5. Y to the 5th. Which means over here I'm going to have to put y. Okay, so what's this left radical? What is the 5th root of y to the 5th? It's y to the 1st, or just y. And then this other radical stays radical. It can't be simplified. So be careful. You will lose a little bit if you leave a radical that can be simplified and you don't. So just be on the lookout for those opportunities. Okay, I need to hurry just a little bit, but I want you to see the difference in number 19. I have 2 different radicals, and it's very important. The directions here tell us to change these to exponential form, exponent form. What is the big difference? I mean, I know that this one has parentheses, this one doesn't, but what does that mean? What does that make these? There's a big difference between these two. How come, Justin?
Second one, both 7.
Okay, I don't know if you heard that, but he's exactly right. On the second radical, because these are in parentheses, both 7 and x are being raised to the 3rd power. Okay? So in other words, I could rewrite this as this without parentheses. Does that make sense? Okay, well, what about over here? Only x is to the 3rd and 7 is to the what? What's the invisible exponent for 7? 1. So I'm not doing any damage if I just do this. All right, now let's write each of them in exponential form. Let's see. Let's go back to Adam. Let's take the left one in exponential form. It would be 7 to the what power? Good. And x would be to the 3/2. Okay. What about over here? Josh, how would you write this in exponential form?
Maybe 7, 3/2, x 3/2.
Very good. And another way of saying that is you could just say all of 7x raised to the 3/2. I wouldn't, in this particular case, it wouldn't bother me either way. Okay, so that leads us to number 25. And Grant, I'll come back to you. I need to change this into exponential form. And we're going to write this one with no parentheses in the answer. 5 to the 6. Okay, all of them to the 6. Now write it in exponential form. Okay, 6/3 is 2. Okay, and then should be fine. Okay, so our final answer, instead of 5 squared, we could just say 25. All right, I just wanted to point out the presence of parentheses and what that means and how it's different when there is no parentheses. All right, do you have any questions, anybody? All right, real quickly, to save time, if you want to review these properties of exponents that you learned in Algebra 1, they're going to be crucial with what we're about to do. You don't have to write them down again, but I know that in Algebra 1 you drilled this a lot. This is when one power is being raised to another power, we multiply the exponents together. We just looked at this one, everything in the parentheses being raised to the power. Same thing here for division, everything in the parentheses being raised to whatever that power is. Well, these rules are going to be very important when we get to problems 38 through 48 even. And here's why. In letter A, I have this monomial 8x to the 15th in parentheses, and this implies that everything in the parentheses needs to be raised to the negative 1/3 power. So I'm going to start with 8 raised to the negative 1/3 power. And when I raise x to the 15th to the negative 1/3 power, we just looked at a rule, just bear with me for a second. When one power is being raised to another power, power inside being raised to a power outside, we multiply those together. So we need to multiply 15 times negative 1/3, and we get x to the negative 5. Okay, now we're back to changing negative exponents into positives. So let's see, I'm going to go back to Caitlin. 8 to the negative 1/3 as a positive exponent would be what? Nice. And I'll stay with you. X to the negative 5 will be nice. Okay. Let's see. Allie, what's another way of saying 8 to the 1/3 power? In radical form. What's the radical form of 8 to the 1/3? The cube root of 8, which is 2. Okay, so instead of saying 8 to the 1/3, I remember that as a radical, that's the cube root of 8. So really that's like saying 1/2 times 1/x to the 5th. Final answer, 1/2 x to the fifth. Okay. Gwen, help me out for letter B. I need, I've got this rule again, a power being raised to another power. Nice. Y to the first. Okay, we don't really need the first. Okay, Gwen, I'm going to stay with you. Change this, first of all, to a positive exponent. Very good. Times y. Okay, Gwen, doing so well. Let's change this into radical form. Okay. All right, and we understand that when we multiply these together, I'm sure you see that 1 times y is just y. And can we simplify the cube root of 8 to the x to the 8th? How, Austin?
Yes.
What will the 2 be? Good. Nice. Okay, give me a final answer, Austin. You're so close. You are so close. What's missing? Anybody see it? Caitlin. Yeah, it should be x squared because 6 divided by 3. Yeah, very good. Good job. So that's not x to the 23rd. I know my writing's kind of sloppy. It's y over x squared times the cube root of x squared. Okay? You guys are doing great. Let's try letter C. Everything being raised to the 4/3 power. Negative 27 to the 4/3. And I just want to see if you catch this. X to the 4th. How did I get x to the 4th? I did 3 times 4/3. It's either 12/3, or you could do this little canceling maneuver, and the 3's cancel and you get 4. Okay, let's see. Sydney, can you give me the radical form of negative 27 to the 4/3? Nice. It's the 4th. So remember, don't do negative 27 to the 4th and then try to find the cube root of that. That's going to be tough. Let's do it easy. What's the cube root of negative 27? Negative 3. Now do negative 3 to the 4th. Should be positive 81. Negative 3 times itself 4 times. X to the 4th. Okay, I think we're going to have time to get through one more of these. So what should I do here on letter D first? Okay, what is the fraction form of negative 0.4? I think we had this a minute ago, didn't we? 4/10, 2/5. So really we need to think about this as 32y to the 5th raised to the negative 2/5 power. Okay, I'm going to go to new screen. So I always recommend that you get rid of these parentheses first. So everything in the parentheses needs to be raised to the negative 2/5 power. And when I raise y to the 5th to the negative 2/5, what do I get? Negative 2. Okay, so Grant, change 32 to the negative 2/5 into a positive exponent. Nice. And do the same thing with y to the negative 2. Okay? And Matthew, what is the radical form of 32 to the 2/5? the 5th root of 32 squared. So again, let's break that up into two parts. What's the 5th root of 32, Bradley? And 2 squared is, so that looked like it was kind of tough, but really it's not. It's just another way of saying 1 over 4. The 5th root of 32 is 2. 2 to the second is 4. Put those together, final answer, Josh.
1 over 4y squared.
Nice. Okay. And I'm going to pause and I'll take care of letter E in just a minute. Okay, so now for letter E, the same idea. I'm going to remove the parentheses by raising everything inside the parentheses to the -9. So remember, when we have a power inside the parentheses times another power, we multiply those together. 1/3 times -9 is -3. And here we're going to have y to the -2/3 times -9. If you multiply those together, you can think of it as 18/3 positive, because it's a negative times negative. So we have 18/3, which is another way of saying y to the 6th. Okay? So I always want to change negative exponents. I never want to leave an answer with a negative exponent. So this x to the -3 is the same thing as 1 over x to the +3. Just wanted to show you that again to drill that property of negative exponents. And so my final answer here is y to the 6th over x to the 3rd. All right, just a couple more examples. For letter F, this is division, and this is, so we have division in the parentheses and this fraction in the parentheses being raised to the 12th power. So I apply that same rule. Each of these parts, x to the 1/3, needs to be raised to the 12th. So that's x to the 1/3 times 12 power, which is x to the 4th. In the denominator, I do the same thing. Y will be raised to the -2/3 times 12 power. And if you multiply -2/3 times 12, you get -8. So it's a very important first step to simplify by raising powers inside the parentheses to the power outside, which means multiply the exponents together. And now I'm going to change the negative exponent into positive. So we can think of it this way. As it is, think of 1 over y to the -8. And to simplify this, we would write the reciprocal of 1 over y, which is y over 1, and then we would change it to +8. So in essence, you could think of it this way. Y to the -8 on the bottom moves to the top as y to the +8. And so that becomes my final answer for this problem. Okay. Letter G is a little different because unlike my problem in F where I'm dividing and I have unlike bases, for G I'm dividing like bases. So you really have a choice here. You could attack this in two different ways. I tend to like to go ahead and combine these using the rule that, I'll just go back to this. Well, I'm not showing that particular rule on that slide. But you remember the rule of division that says if you're dividing like bases, then you can just write the base and subtract the exponents. We've talked about that rule in this class before. So that's what I'm going to do here. I'm going to take these two x terms, these monomials, and rewrite them by subtracting the exponents. Right, and so that's going to consolidate two different x's into just one single x to the 12th, and now that's going to be raised to the 1/5. So all I did so far is simplify this fraction in the parentheses. I took two x's and converted converge them into 1. Now I'm going to do the power 12 raised to the power 1/5, and that gives me x to the 12/5. Change this into radical form. That's the 5th root of x to the 12th. I can simplify this because 5 is lower than 12, so I'm going to use two groups, two 5th root radicals. And I'm going to use x to the 10th because 5 does divide into 10 evenly. And over here, I'm going to have to use x to the 2nd. And simplifying the radicals, the 5th root of x to the 10th is x squared. And this is just going to be the 5th root of x squared. So that would be the final answer for this example G. Okay, gave you a lot of examples, and I hope that will help you with the homework assignment, which is given there. And so bring your questions to class, or you can send me an email if you have trouble.